For the pre-calc review, we start off by reviewing trigonometry and finding the values of trig functions at certain angles. So first we want to find the cotangent of -3 pi over 4. I highly suggest drawing the triangle and then finding the trig value. So -3 pi over 4, if we draw the unit circle, is in the third quadrant because we want to go in the negative direction. And then when we make our triangle, we always want to attach it to the x-axis. And we want to remember that anytime we have pi over 4, we're working with a 45-degree angle. So the sides of our triangle are going to be 1, 1, root 2. And then also we're in the third quadrant, so both of the sides are negative. And then we also want to remember that cotangent is the inverse of sine, or the reciprocal of sine. So tangent would normally be -1 over -1, and cotangent would be the same, just flipped over. So the value is 1. For -5 pi over 6, that is also going to be in the third quadrant. And anytime we have pi over 6, we want to remember that that's a 30-degree angle. So the sides of a 30-degree angle are 1, root 3, and 2. And both of these sides will be negative. The sine is opposite over hypotenuse, so our answer is -1/2. 10 pi over 3 is over 2 pi, so we want to find a coterminal angle before we draw it. So if I subtract 2 pi from 10 pi over 3, it's kind of like I'm subtracting 6 pi over 3. So we really want to find the cosine of 4 pi over 3, since they're the same angle. So 4 pi over 3 is, if we start at 0 and go around counterclockwise, it would also be in the third quadrant. And whenever we have a pi over 3, that's a 60-degree angle. So we have a root 3, a 1, and a 2. And both of these sides are negative since we're in the third quadrant. The cosine is adjacent over hypotenuse, so it would be -1/2. For the cosecant of pi, we want to realize that pi is a quadrant angle, and so to find any trig value, we need to use its coordinate, which is -1, 0. And cosecant is the inverse of sine. So if the sine of pi is 0, because sine is always the y value, then the cosecant would be 1 over 0, which is undefined. For -3 pi over 2, that is also a quadrant angle, and -3 pi over 2, if I start at 0 and go all the way around, is actually the same as pi over 2. And its coordinate is 0, 1. We want to remember that tangent is the same as y over x or sine over cosine, so 1 divided by 0 is undefined. For the secant of pi over 3, we want to draw pi over 3, which is in the first quadrant. And we want to remember that that's a 60-degree angle, so the sides are going to be root 3, 1, and 2. Secant is the inverse of cosine. So if the cosine is 1/2, the secant is going to be 2. Now we're going to move on to some inverse trig functions. So for these, we want to remember that there are going to always be 2 answers for theta if we're looking for theta in between 0 and 2 pi, because the trig value can exist in 2 different quadrants. So for these, we want to remember about all students take calculus in order to remember what quadrant we should draw our triangles in. So for the first one, tan theta equals 1, you might think that that's on a quadrant angle, but it's actually a triangle because we have a triangle where both sides are 1 and 1 over 1 equals 1. So tangent is positive in the first and third quadrants. And the sides will be 1 and 1 in order for our tangent to be 1. The third quadrant, it's -1 and -1. And we know that this must be a 45-degree angle. But we want our answers in radians. So our first radian will be pi over 4. And our second radian, since it's in the third quadrant past pi, is going to be 5 pi over 4. For number 8, we want to find the cosine of -√3 over 2. So cosine is negative in the second and third quadrants. And we know the adjacent side is -√3, and our hypotenuse is 2. And the side that we're missing is 1. And so the angle across from 1 must be a 30-degree angle. So we're dealing with the pi over 6s, since we have to be in radians. So since I'm just before pi and just past pi, my two answers are going to be 5 pi over 6 and 7 pi over 6. For number 9, we have cosecant of theta equals √2. It may be easier to change cosecant to a sine, since sine is the inverse, and instead answer the question sine theta equals 1 over √2. So sine is positive in the first and second quadrants. And we know that the opposite side must be a 1, and the hypotenuse is a √2. So we're dealing with 45-degree angles. So since we're in the first quadrant, pi over 4 will be our first angle, and 3 pi over 4 will be our second one, since we're in the second quadrant. For our last one, we have the cotangent of theta equals -√3 over 3. Again, it might be easier to change it to tan theta and flip it around. So we have -3 over √3. And then do some rationalizing. So we end up with -3 √3 over 3. And then our 3's cancel out. So we just are looking for where the tangent of theta equals -√3 over 1. So tangent is negative in the second and fourth quadrants. And we know that our opposite side is √3 or -√3. And our adjacent side is 1 or -1. So we must be dealing with a 60-degree angle, which is the pi over 3's. So since we're in the second quadrant, we have 2 pi over 3 as one of our answers. And in the fourth quadrant, we have 5 pi over 3.